Today we're going to be talking about interior and exterior angles and circles. Our objective is that we will be able to use angles, arcs, chords, tangents, and secants to investigate, verify, and apply properties of circles. We will also be able to find angle and arc measures created by central and inscribed angles. So the first thing we're going to talk about is an inscribed quadrilateral. All the vertices of the quadrilateral are on the circle. And the special thing about these inscribed quadrilaterals is that the opposite angles are supplementary. Which, in case you've forgotten, means that they add to 180 degrees. So, angle D and angle F will equal 180 degrees, and angle E and angle G will equal 180 degrees. So let's use that to help us solve this example. Angle P and angle R would have to add to 180 degrees, so 63 plus 3x equals 180. And angle S and angle Q, so 4y minus 1 plus 65, would have to also equal 180 degrees. If we subtract the 63, we get 3x equals 117, and x equals 39. For our other equation, I'm going to combine like terms first. 4y plus 64 equals 180. Subtract 64, we get 4y equals 116, so y equals 29. Now for angles in the interior. The vertex is inside the circle, but not necessarily at the center. So let's look at angle 1. We know angle 1 would be congruent to the angle across from it because they're vertical angles, but we want to look at the two angles they intersect. So angle 1 intersects arc AC, and the angle across from it intersects arc DB. So the angle will equal half of the two arcs combined that it intersects. So in this example, the measure of angle 1 would equal half the measure of arc AC plus the measure of arc BD. So let's look at some examples. We want to find angle X. On the left-hand side, it intersects angle MQ, and on the right, it intersects angle NP. So X would equal 1/2 of 110 plus 30. Simplify our parentheses, it's half of 140, so X would have to equal 70 degrees. In our next example, this time the X isn't the angle, it's part of the arcs. So let's look at the arcs it intersects. Intersects arc WX and arc YZ. So we know that 45 must equal half of 2x plus x. Multiply by 2 to get rid of our fraction there. Multiply by 2, we get 90 equals 2x plus x would be 3x. Divide both sides by 3, and we get that x is equal to 30. So that's interior angles. Now let's look at angles in the exterior. Angles in the exterior, the vertex is outside the circle, like angle 1 here. So if we highlight the arcs that it intersects by lighting up the angle, it intersects the big arc BC, and it also intersects the small arc AC. So that in this case, when the angles are in the exterior, the measure of the angle, is going to equal half of the big arc minus the little arc. And we're going to subtract the little from the big because we don't want a negative number. So in the case of angle 1, the measure of angle 1 would equal half the measure of arc BC, because that's the bigger one, minus the measure of arc AC. So let's look at some examples. Here, angle X would equal half of the big arc's 138 minus the little arc of 66. The X is by itself, so we just need to simplify. Half of 138 minus 66 leaves us with 72. Half of 72 means X equals 36 degrees. In our next example, it's a little harder to see. It intersects the sides right here. We have two tangents. So the big arc is 260 degrees, but we don't know what the smaller arc is. It's not labeled. But since the way that these lines intersect our circle, the big arc and the little arc we know make up the entire circle. A whole circle is 360 degrees. So if the major arc's 260, that leaves 100 for our small arc. So X would equal 1/2 times 260 minus 100. So it would be half of 160, which means that X must be 80 degrees. For our last example, we're going to have to do a little more algebra because our arcs this time are expressions. So we know our angle 61 has to equal half of our big arc minus everything that's part of the little arc. So 5x minus 1. Let's simplify what's in these parentheses. So 61 equals 1/2 times, I'm going to bring down the 10x plus 1. Because this negative, this minus, is for this whole expression, because this whole expression was our arc, we need to distribute the minus. So minus 5x plus 1. Then I'm going to combine like terms. 61 equals half of 10x minus 5x would be 5x. 1 plus 1 is 2. I'm going to multiply both sides by 2 to get rid of the fraction. So 122 equals 5x plus 2. Subtract the 2. 120 equals 5x. So x is equal to 24. Finally, for your summary, summarize how to find the measure of an angle in the interior of the circle and how to find the measure of an angle in the exterior of the circle. That's all for today. I'll see you in class.